Today we're going to look at chapter 6, which is entitled An Introduction to Geometry. And in 6.1 we're looking at basic geometric figures. The first geometric figure that we're going to look at is a line segment. Notice that in this line segment there's a beginning point, there's an ending point, and there's a straight line drawn through that. A line, notice that was a line segment. That's where you had distinct endpoints. A line is where you have arrows on the end to denote that it keeps on going out to the left, it keeps on going out to the right, but they label 2 points on this line, A and B. Array is where it's a fixed point, boundary point. It consists of a fixed boundary point and the portion of a line on one of its sides. So this is the fixed boundary point, and then the arrow goes out. Part C here is an angle. This is the vertex of the angle. You have basically it's two line segments with a distinct point in common. Excuse me. No. That's the angle there. I'm sorry. Okay. So part C is it's the rotation of a ray about its end point is an angle. In part D, this is an angle as well, and it is denoted as angle BAC. Notice that the point that BA and CA have in common, that is the middle letter, BAC. We have some special type angles. We have a 360-degree angle. That's where you'll start at a particular point and you go all the way around and you end up back on the other side of that point. 360 degrees. 180 degrees, that's a straight line. 90 degrees is a right angle. So two perpendicular lines make a right angle. We have what's called acute angles, and we have obtuse angle. An acute angle is an angle that's less than 90 degrees. It's between 0 and 90 degrees. Remember, a 90-degree angle is a right angle, and an obtuse angle is between 90 and 180 degrees. Okay, so we have acute angles and we have obtuse angles. We have other angles. We have complementary angles and supplementary angles. If the sum of two angles is 90 degrees, then they're complementary angles. If the sum of two angles is 180 degrees, then they are supplementary angles. So in part A, we have two complementary angles. Together they form 90 degrees. And in part B, we have two supplementary angles. They together form 180 degrees. Now, when we talk about angles, we typically refer to them as degrees, but if we want to get into a different part of a degree, let's say something that's less than 1 degree, then we need to break the thing down into minutes and seconds. We use a little tick mark. 1 tick mark to denote minutes and 2 tick marks to denote seconds. Okay. We say that 1 degree is 60 minutes, and of course 60 minutes or 60 seconds is 1 minute. Okay, so what you have to do is to divide these portions of angles into different parts of 60. So in the next couple of examples, they want us to express each angle in degrees and minutes. Here, like I said, when it's something less than 1 degree, then you can put it to degrees, seconds, minutes. Here you have 18.9 degrees. So the 18 is just the 18 degrees. And the way we get the minutes part is we take our 0.9 and we multiply it by 60 minutes. Remember, we said that there are, in 1 degree, there is 60 minutes. So 0.9 times 60 is 54. So 18.9 degrees is 18 degrees and 9 minutes. Remember, excuse me, not 9, 54 minutes. I'm sorry. 18 degrees and 54 minutes. Okay? Remember, degrees is a circle up here. Minutes is the little tick mark. And number 8, we want to look at 79.05 degrees, and we want to translate this 0.05 degrees into minutes. We're going to multiply by 60 minutes. And 0.05 times 60 is 3. So this becomes 79 degrees and 3 minutes. 79 degrees and 3 minutes. Now we have a couple of examples where they want us to express each angle in degrees and a decimal part of a degree. So if you remember what we did in the previous problems, to get the decimal part of a degree to minutes, we multiply by 60. So here we're going to do the opposite. We're going to divide the 48 minutes by 60. So 48 divided by 60 is 0.8. So this becomes 33.8 degrees. So in number 12, we take our 57 minutes and we divide by 60. And that's 0.95. So this becomes 16.95 degrees. All right, so now we're going to look at triangles. We have special triangles. Remember that a triangle has 3 sides, 3 angles. We have an equilateral triangle if all of our angles are the same. And if all of our angles are the same, then all of our sides are the same. You have 60 degrees. This angle, 60 degrees, and the side opposite are related. Okay? Here you have an isosceles triangle. You have 2 sides that are equal, and their corresponding angles are equivalent as well. A scalene triangle, you have no sides being equal. And since no sides are equal, then no angles are equal. We have a right triangle. Right triangle means there's a 90-degree angle, and the side opposite of the 90-degree angle is called the hypotenuse. And then you have the other 2 sides, which are legs of the triangle. We have some other geometric figures. We have a quadrilateral. Okay, quadrilateral is a closed figure, plane figure that has 4 sides, and you have 4 angles. Okay. Part B, you have a parallelogram. In a parallelogram, these opposite sides, B and C, are parallel. A and B are parallel. And parallel lines never intersect. Okay. Part C, you have a rhombus. And with a rhombus, it's a parallelogram where all sides are equal. Part D, you have a rectangle. You have the four sides, and they form 90-degree angles each corner, and the two opposite sides are equal. So B is equal to this side, and this side is equal to that side. They're parallel lines as well. And these intersecting sides, they form 90-degree angles, which means that they are perpendicular. Then we have a square. A square, all sides are equal. Again, the intersecting sides form right angles, or they are perpendicular. And then part F, we have a trapezoid. Okay? Part F, we have a trapezoid. And a trapezoid, two sides are parallel, exactly two sides are parallel. So these two sides here are parallel. The other two sides are not parallel. And these parallel sides are called the bases of the trapezoid. Okay. And we also need to talk about circles. Okay? Circles. We have a fixed point on a circle that's called the center of the circle. And from the center to any point on the circle, it's the same length. So the radius is from the origin to any point on a circle. But if you go from one end point to another end point going through the origin, then that's the diameter. The diameter is 2 times the radius. So you may have problems where they give you the diameter, or you may have problems where they give you the radius, but just know that the diameter is twice the radius. Alright, so next we're going to look at a few problems. In exercises 13 through 19, it says use this figure to identify the indicated angles. It says EB is drawn perpendicular to AC. And in number 14, they want us to find the straight angle. The straight angle is 180 degrees. So 180 degrees will go from here to there. So we can call that B our vertex. This is the angle ABC. That's our straight angle. Number 16, they want us to find the acute angle adjacent to DBC. So what is DBC? Let's put DBC in red. This is DBC. And they say the acute angle. Acute means less than 90 degrees. Okay? So they want the acute angle adjacent to DBA. So adjacent means that we're going to share a side. So we're going to share this BD side. So that's going to be angle EBD. Angle EBD. All right, number 18 says that if angle CBD is 65 degrees, find its complement. Remember that complementary angles have a sum of 90 degrees. So its complement is 90 degrees minus the 65, which is 25 degrees. That is its complement. In the following problems, we're going to use these figures that we have over here to answer these questions. Number 20, it says identify the isosceles triangle. The isosceles triangle. And we're looking at this picture here. We're looking at this picture here to identify the isosceles triangle, figure 16.14a. Now, an isosceles triangle has two sides that are equal. So we have this side that's equal and this side that's equal. So this is the isosceles triangle. And it is going to be the triangle CDB. CDB. It says in figure 16.14a, the same figure, identify the right angle, the right triangle. The right triangle, whenever you have a right triangle, they put a little square here. It's going to be CDA. And number 24, it says to look at figure B. So we're looking at this one now. Identify and determine the lengths of the legs of the right triangle. So remember, this long side opposite the right angle is the hypotenuse, and the other two are the legs. So leg 1 is 3 inches, and leg 2 is 4 inches. Number 28, they want us to look at part C. So we're looking at this one. In the parallelogram, it says if the angle ABC is 135 degrees, then what is the angle CDA? Well, in this case, the angle CDA is opposite this angle ABC, and with parallelogram, opposite angles are equal. So this angle CDA is 135 degrees as well. And number 32, we're looking at this figure F here. It says identify the radius. Now it tells us from A to B is 8. And we know that the diameter is 2 times the radius. So the radius is half the diameter, which in this case is half of 8, which is 4. It's 4, but the radius is the line segment OB. Or you could say it's OA. So they didn't want us to actually find the radius. they want us to identify. You could do OA or OB. Let's look at another question. Number 48. It says an airplane and a helicopter take off from the same spot. The path of the airplane makes an angle of 40 degrees with the ground, whereas the helicopter goes straight up. What is the angle between their flight paths? So an airplane and helicopter take off from the same spot. The path the airplane makes is at an angle of 40 degrees with the ground. This is the airplane. It says whereas the helicopter goes straight up. What is the angle between their flight paths? So what we want to find is this angle right here. Now, saying that the helicopter goes straight up and that the airplane is 40 degrees from the ground, this makes a 90-degree angle. So what that tells us is that these two angles are complementary. So remember, complementary angles have a sum of 90 degrees. So 90 minus 40 gives us 50 degrees. And that is the angle between the paths. Look at number 50. A circular access road is to be constructed around an office complex. If the distance between the center of the office complex and the road is 400 feet, what is the diameter of the circle formed by the road? So basically, you have a circular path there. This is the center of the complex. This is the road. And they want to know the diameter of this circle. Remember that the diameter is 2 times the radius. So we have a diameter of 800 feet. 800 feet.